Yeah, welcome to this tutorial. This is for GT 209, which is we all know as engineering maths, the total derivative. So we're given this question. Define the total derivative of du dx, du dt, and verify the results by direct substitution. Then we're given u as a function under the with respect to x, y, and z. So and you are asked to look for the udt. You can see this function is not with respect to t. But you have each of these x, y, and z that has a function of exponential respect to t and cos with sign also. So although you don't have anything that is with respect to t here, you can use the formula of total derivative, which is since you have to look for du dt, you have to make a formula for du dt that can be gotten from x, y, and z. And how do we do that? Remember, change rule. So if you are using, you can say du dx multiplied by dx dt. And if this dx cancel dx, you have du dt. You can also, if you change this one to y too, you have du dy multiplied by dy dt. So you can also use that one to get du dt again. And so you can also change it to du dz multiplied by dz dt. You can also use that one to get du dt. So you are going to be using those three formulas. The sum of those three formulas will give you du dt. So without wasting our time, let's bring out the formula out. So we have to look for du dt. Du dt will be into brackets for x. It will be du dx multiplied by dx dt close bracket plus du for y now, du dy multiplied by dy dt. That's for y. Then for z, you have du dz dot as dz dt. So these are the formulas we are using to get du dt. You can see that from here now, we are getting for x now, we are getting the part we are going to use for x. We are getting the part we are going to use to get du dt from y, and we are getting the part we are going to use to get du dt from z. So, but I want to chip in something. When writing your derivative, we have partial derivative and total derivative. Partial derivative is written as this. You can see. Then total derivative is using the normal d. And that will make me change this and this and this to partial derivative. Why is it partial? Look at this place. We are having a function of x squared. This is du dx. That means they told you to partially differentiate u with respect to x. That means you are leaving the rest and you are facing only this x. That's the meaning of that. Is that part only you are facing. So that's the meaning of partial derivative. So I will just change this to du d, then partial derivative. So when you are writing your formula, please take note of this. You have partial here also, du dy, and you also have partial here also, du dz. Now we have our formula ready. So let's think we are following. Okay, now we now start solving one after the other. Du with respect to x, u with respect to y, and u with respect to z. So let's start. Let's start with du dx partial derivative. Remember, du dx will be what? So when we differentiate this will be what? 2x for this. Then partial differentiation of u with respect to y will be 2y. Then partial differentiation of u with respect to z will be what? 2z. You can see that we took them part by part. That's why it is called partial derivation. If it's that it is full, they will have given you another x here that you'll be able to deal with all the x that is in that equation. But now it is partial. We are done with this and this. Now let's face this and this, and you can get those from here because we have x. You can differentiate x with respect to t here. You can differentiate y with respect to t here. You can also differentiate z with respect to t here. And now it is total differentiation because there's no how to, so here we'll be using either chain rule, product rule, and all those differentiation rules. So now let's move. We want to differentiate dx dt. Remember, we have e exponential raised to power 2t. In these cases, it is more advisable to use shortcuts. You can also use the long way, but in times of exam that you need to, you need to be fast. So you have to use some kind of shortcut that will help you. When you are differentiating this, you pick the coefficient of the power to the back, then multiply by what you are differentiating. When you are dealing with exponential, so the answer will now be what? 2 multiplied by e raised to power 2t. That would be your differentiation. I don't think you get like that. So we also have this formula we normally use for it. You have the formula that says partial differentiation of du over u will be due raised to power u. That is the differentiation of this. The differentiation of this, which is 2 in this case, then the u, which is this, and raised to power that's e here. This is the exponential here, then this is the u. The u takes the power. So but for my own method, actually I will just differentiate this and I'll multiply it by all of that and I will get my answer. So for this one, the division of the u dx without wasting our time will be 2 exponential of 2t. Now for the y dt now, sorry, it should be total. The y dt. So you can see that this is product rule. You'll be using product rule here and you also use chain rule here. Thank God we have gotten the derivation of this, but we still need to get the derivation of this also, so that we cannot use product rule. The big gets. But I also have a method again for this also, and it is very, very easy to assimilate if you really calm down. So on the nose, the formula for product rule is supposed to be dy dx is equals to u dv dx plus v du dx. Yes, that's the formula for product rule. So you can now relate this to this. Imagine this is our u, and this is our v. So I will just, without wasting my time, I will just use the differentiation, this formula, to get my answer direct. And how? I will, this is the normal u here. I will bring it out as, this is the normal u, this is u. I will bring u out and say that e exponential raised to power 2t multiplied by, I am differentiating my v. I'm differentiating my v this here. So if I want to differentiate something like this, it's also similar to the exponential. You just differentiate this 3t. When you differentiate this 3t, you now bring this 3 out, then you differentiate this cos and write the 3t again. Do you get? So it will now be, this is cos 3t here. Now I want to differentiate this. Let's say y is equals to this. Now I want to differentiate this now, the y dt, without wasting my time. This is 3t. I differentiated this 3. 3t becomes 3. Then I differentiated this cos, it becomes minus sine. Then I bring this 3t down again. That's just it. I got in my derivation. So for this one now, I did not differentiate this at the first time. I differentiated this on the first side. That's when I differentiated this, I got minus 3 sine 3t. Then you now put the plus there, the formula, plus, what's our v? You write it normal without differentiating it. You can see cos 3t, then multiply by what? You now come and differentiate the one you not differentiate before, which is this. And when you differentiate that, remember we got this the other time. So you have dot 2 exponential 2 raised to, that's just it. So let me write it very well now for us so that we can continue. Maths is very, very interesting. It just depends on how. So this one will be in, let me write it with a normal pen. Minus 3 sine 3t plus cos 3t dot 2e 2 exponential Yes. So we can just put this into brackets. Let's put this into brackets so that we will not confuse ourselves. So that is our dy dt. Now for dy dt, dz dt rather. For dz dt, we will do the same thing we did before using the normal product rule. So we are not differentiating this. We differentiate this on the first hand side, then plus we will differentiate. We are not differentiating this. They will not come and differentiate the one we not differentiate before. So let's start. We are not differentiating this the first time. So we have e exponential 2t into brackets. We are differentiating this now. So if you differentiate this, you have 3. You know, I said you bring this 3 out first. Differentiating that 3 you have 3. Then what's the differentiation of sign? That's cos. 3 cos, bring that 3t down like that. 3t plus. Then the other side now, what are you differentiating? You are not differentiating this again because you have differentiated before. So we have 3 sine 3t. Then into brackets, we will now come and differentiate this that you not differentiate before. Into brackets 2e raised to power 2t. So can we see? Now that we have gotten all the parameters, we can now go ahead to insert them into the formulas. So we want to continue from where we stop. Here we want to reschedule this very well. These two, we want to make this exponential raised to power 2t separate. So we can write it as exponential raised to power 2t open brackets, or let's just use dot 3 minus 3 sine 3t plus these two come outside here. So I want to make this one below, so to be 2 cos 3t then exponential 2t. So from here we can, since exponential 2t are common on both sides, we can make it, we can factorize it. So I think we understand that. So let me do it here. Let me do it down here. So we now have our dy dt as when we factorize these two outside, we have exponential 2t into bracket of, we bring this one minus 3 sine 3t. No close the bracket here, don't close the bracket here. So plus, now we are factorizing this and this, you have this plus 2 cos 3t. So I think that is done for that one. So for this one also, let's make this alone. I want to make this exponential 2t alone. So bring this to here to multiply this. We get, so we have exponential 2t 3 cos 3t plus this one will come and become 2 sine 3t then exponential 2t. So we also factor. So from where we stop, so we just start to pick them now. These are 4x. 4x doesn't have any value. So it will be 4x. Our exponential is power 2t is x. So let's put x there. X. So plus 2y. 2y doesn't have any. Then this is minus 3t. But this one here, exponential 2t sine 3t. So that's z. So we just have to write minus 3z. Minus 3z into bracket because you know there's multiplication here. Minus 3z plus then 2 what is exponential? That's y plus 2y then plus open bracket 2z. Let's put it outside 2z. Then you shall now open the bracket 3 exponential. This is y. Then what do we have again? 2 exponential sine 3t is what? Z. So you can see that we have put all our values into this place. So let's now simplify well enough. So we have 4x squared, x multiplied by x Then use this two to open the bracket. You have minus, let me just put this as minus 6 yz. Here too we have plus 2 times, and that's 2 times 2, that should be 4 y square, then plus, if you multiply this, you have 2 times 3 6, then yz, and plus 2 times 2 is 4z square. So what do you do? Notice that this and this cancels themselves. Am I right? Yes. So we have only this and this. So what do you have there? You have 4x squared plus 4y squared plus 4z squared. Can you see? So and what is, you can factorize 4 outside. 4 is common in everywhere. So you have 4 into brackets x squared plus y squared plus z squared. And what is this in the equation? It is u. So our answer is for you. So that's just for this one. Thank you for watching. Help us like, subscribe, and comment. Also share. Thank you.